G'day there, boys and girls. We're out here to have a look at superposition of waves today. Superposition, I hear you ask. What's that? Well, we sometimes talk about things being superimposed upon each other. You probably haven't heard about it in physics before, but when we talk about things being superimposed upon each other, usually two things kind of occupying the same position, maybe in time, maybe in space. With waves, we're talking about exactly that. Two waves occupying the same position on a medium. What happens? And I've drawn some pretty theoretical waves here, the red triangle one and the blue square one, just so that we can keep track of them. They're not waves you often see in everyday life, but we could make these, particularly with electronics. We could make these waves and send them flying around, and we would see exactly this. And so what we're interested in is, what do we see as these two waves occupy the same position on the medium? Well, it turns out that at the instant that they're perfectly aligned with each other, like that, we're going to see the two waves actually passing through each other, just like that. But that's not what we're going to see the medium do. What we're going to see happen is interference. We're going to see the blue square wave interfering with the red triangle wave, and what we'll see is the addition of those two waves. And so the medium is going to do something like that. At the instant that those two waves are passing through each other, it's going to be the blue one with the red one stacked on top of it. And so we're going to end up with our medium doing something like that. And then, what about what happens after they've passed through each other? Well, turns out, of course, that these two things, these two waves, are just pulses of energy. And so after they pass through each other, they just continue on their merry way, unaffected. It's only as they're passing through each other that we see that weird phenomena of interference that goes along with superposition. Not much of a change, is it? We've just flipped one of those waves the opposite way up. If you're a brave soul, what you could do is pause this video right now and have a go at seeing if you want to have a guess at what happens before I draw it out for you. Otherwise, just keep watching and I'll do it for you. Once again, at that instant, as they're perfectly aligned on top of each other, we see them occupying the same position on the medium. But what is it that the medium actually does? Well, look, the tippy tip of the red one is going to completely cancel off the tippy tip of the blue one. And so right there, that medium's going to do nothing. But over here, the red one is nothing and the blue one is something. And so the medium's going to be out there, and so our medium, what it will actually look like at that instant right then, is not like either wave. It's going to look kind of like a green upside down triangle wave. And then afterwards, once again, these two waves pass on their merry way, unaffected by each other, unaffected by having passed through each other. That's okay. Like that. And so that's really the basics of superposition, and we also talked a little bit about interference. So we're just going to keep talking about that idea of interference a little bit more and think about what would happen if we superimposed like more realistic waves, what we might find in real life, like could be a light wave, could be a sound wave, could be a water wave. What would happen if those two waves met up on the same medium at the same time? And to understand what would happen, what we have to do is check and see. The crest of the red one lines up with the crest of the blue one. The trough of the red one lines up with the trough of the blue one, and all of the crests and all of the troughs line up beautifully. We notice that they've got the same wavelength, in fact that they're identical waves to each other. And so when they line up beautifully like that, we say that they are in phase with each other. And when they're in phase with each other, we're going to get, when they're superimposed, we're going to get interference that results in something bigger. Look, it's exactly the same in form as each of the waves, but much greater in amplitude. And when we get two identical waves adding together to get something much bigger, we call it constructive interference. Now, constructive interference and the fact that those two waves are in phase are two ideas and pieces of vocabulary that I would like you to commit to memory. What about if we move them a little bit so they're not lining up anymore? What if we make them so that they line up anti-perfectly? You might have spotted that all I've done is I've shunted the blue one along half a wavelength. I've just moved it along half a wavelength that way. And now the crest of the blue one lines up with the trough of the red one, and the crest of the red one, what does that line up with? The trough of the blue one. And guess what? When we add those two together, we get diddly squat, zero, nothing. If it was light, we would see dark. If it was sound, we would hear quiet. If it was water, it would just be flat. And we call this destructive interference. And when those two waves are like that, there's two different ways we can write about how they're aligned with each other. We can either say that they are 180 degrees out of phase, or we can say that they are half a wavelength out of phase. It's not enough just to say that they're out of phase with each other, because anything that's not in phase is out of phase. We have to say how much out of phase they are, and that's either half a wavelength, or thinking about this as a sine graph, that half a wavelength is actually just 180 degrees, but there'll be more on that later in maths class, no doubt. So destructive interference, if it's light, it means dark. If it's constructive interference of light, we'd expect brighter light. Destructive interference of sound, quiet. And yet, if it's constructive interference of sound, it's louder. Water waves, we're expecting to see really big waves when there's constructive interference compared to flat ocean when it's destructive interference. And I'm going to be sending you guys through a few examples of this to get on with. Cool?